Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's the problem for today for exam P on probability. An insurance company studies back injury claims from a manufacturing company. The insurance company finds that 40% of workers do no lifting on the job, 50% do moderate lifting, and 10% do heavy lifting. During a given year, the probability of finding a claim is 0.05 for a worker who does no lifting, 0.08 for a worker who does moderate lifting, and 0.20 for a worker who does heavy lifting. A worker is chosen randomly from among those who have filed a back injury claim. Calculate the probability that the worker's job involves moderate or heavy lifting. And here's a solution. We begin by labeling the events. C is the event that the worker files a back injury claim, C for claim. N is worker does no lifting. M is worker does moderate lifting. H is worker does heavy lifting. And we're actually given the probabilities of a claim given that N, then given that M, and given that H. We are looking for the probability of M union H given C. So conditional probability the other way. And of course, every time you have this kind of flip-flop of conditional probabilities, it's a Bayes theorem problem. Here, it's a union of two events, so it's a bit inconvenient, but we see immediately that probability of M union H given C is 1 minus the probability of N given C, because M, N, and H form a partition of the probability space. Then, using Bayes' theorem, we just write this probability that probability of N given C is probability of C given N times probability of N. So flipped conditional probability times the probability of N. And then at the bottom we have the same thing as at the top, but for all pieces of the partition, so for N, M, and H. And that's equal to, all of these numbers are now given in the problem. So this is equal to 0.5 times 0.4 over 0.5 times 0.4 plus 0.8 times 0.5 plus 0.2 times 0.1. And that's equal to 0.25. And then the probability of M union H given C is 1 minus the probability of N given C, so it's 1 minus 0.25, which is 0.75, and that's answer A. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.